Hello, am I not muted? Hello, and welcome to another exciting episode of Cooking with Unity. I'm your host, Maximilian Moreau, and with me is my co-host, Philip Wilson.
I'm here.
He's here. So, let's get right down to brass tacks. So, main screen. I didn't say it.
It's you.
So, what we've got going on in our project so far is we have a broken wind condition. As you probably remember last time, we were setting up the wind conditions, and we did a really quick and dirty number on it. And the problem right now is when we hit the wall, basically anywhere, it says "Game over, you win," which is cool, but also not cool. So.
Is it actually because you hit it anywhere? Or is it because it actually hits the red?
It's because
hot tamale?
I think it's because the bricks are hitting the hot tamale. So let's test that by making it so that we actually check to see what layer the object is on.
Alrighty.
So let's go to our what is it called? Player 2 base wall spawner. What's the actual? Fortress Hearts. There we go. Fortress Heart 1, Fortress Heart 2. So let's grab this Fortress Heart and let's change the way that it collides. We're going to call this, we're going to add a layer called Heart, is what I'm going to call it.
Heart layer?
Yeah, Heart layer.
You could call it the Mati layer.
The Mati, yeah. From Captain Planet.
Yes.
I was looking at the cast for that recently. It's got an all-star cast. Have you actually looked at the IMDb?
No,
it's wild. Like, it's crazy. Yeah, you might want to check it out during the show so you can just start giggling. But
I do like giggling.
So let's see what we got. Let's fix that real quick. I don't want this program on. I need to add that to my list of things to disable. All right. So our Fortress Heart now isn't actually set to that layer yet. We just made it, so let's set them to Heart. And let's change the collision settings on that so that you have to hit directly with the cannonball. So let's look at our cannonball real quick and make a collision thing for that. So cannonball has a sphere collider. There we go. So we're going to do layer, add layer, cannonball.
So excited to see LeVar Burton was in it.
Yeah, exactly.
It's amazing.
Okay,
I need to get off.
Yeah, this object only. All right. So we have a cannonball, and so what this cannonball is going to do is we're going to make sure in project settings, physics, we've got our little collision thing here, and so we want to make sure that the heart only collides with the cannonball. So Heart collides with Cannonball. Cannonball can collide with everything else. We don't care. We just don't want Heart colliding with anything else. So that will solve our problem right there, hopefully.
Theoretically.
And so if we launch a ball out here...
There's also a possibility that it's breaking through the wall.
It's not.
Oh, no. It was definitely that.
Yeah.
Neato. Now it's just not instant win.
Yep, now it's not instant win, and now I'm just going to see if I can tunnel in to enough to actually hit the thingy.
The heart piece?
The heart piece, I like that.
Keep tunneling.
This doesn't seem like it's doing so great.
No. I think things are happening. Things could be happening.
About something. I want to just make sure that these cubes. I'm going to pick one of these cubes out, and okay, yeah, they're not kinematic, so that's good.
Yeah, but is it destroying the cannonball right when it gets to it still?
It is, but it should be applying a explosion force, and we want it to actually go through the wall completely. Like we want it to be a clean hit. So let's actually play with our cannonball settings real quick and make it so that it's explosion force. Let's make it 75. So we get a little bit more wall action here.
Is it doing just an upward force?
No, it should be doing an outward force. I don't think it's doing any upward or any additional upward.
Yeah, it should certainly be doing an outward force.
And let's increase the explosion radius a little bit too. Let's go 5. Just double it. Why not? See what
When all else
happens
fails,
now.
double it. That's kind of like the way I live my life, really.
Ooh, that did some damage.
Whoa. Isn't that a good motto to live your life by? If all else fails, double it.
I'm just gonna shoot again.
Boom!
Oh yeah, that's looking more like
Yeah,
what I want it.
that's fantastic. Yeah, I like that. Oh, look at the
That's
bricks
really
fall.
cool,
That is
actually.
awesome.
That's really cool. And this should go right in. Game over, you win! Alright, so that solves that part. Now, it's still switching to the other player, which means we can still do the game. All we have to do to fix that is... Where are we actually checking game over on this thing? Turn manager, maybe? Win. Okay, no, we're not
I
checking
have
it here.
no
It's in...
idea.
It's in... Cannonball? No. It has to be on the Fortress Heart somewhere. You win. Script. Where is that? Oh, it's not in our scripts. Let's drag that into scripts so I can
Well, that
find the
would
future.
help.
And so all we're gonna do is so we call turn manager win here, and so what we're gonna do in turn manager win. The problem is we're still switching because we have a invoke that's called, and so we need to cancel the invoke, and I actually don't remember how to do that, so I'm going to do Unity cancel invoke.
It's like you stop all coroutines or something like that.
Yeah, that's if they're
But
coroutines, but this is not a coroutine.
Oh,
This
yeah,
is an
right.
invoke, so I think.
Yeah, it's an invoke.
Yeah,
It's
all of these
definitely
are
an
invokes.
invoke.
Okay. So cancel invoke. Cancels all invoke calls on this model behavior. Well, that will suffice. So we'll just throw that into our win script here. So hopefully what'll happen now is when we hit play and we launch our projectile.
That's a projectile.
I'm just gonna
Dig the way it impacts the wall now, by the way.
Yeah, me too. It's pretty awesome.
That was cool. Also cool.
It's looking good. It's looking real good. Game over, you win. Alright. So now we shouldn't have... Okay, so we can look around, but yeah, we don't have the ability to launch anything anymore. And if we hit enter, it reloads and everything works. So now we've fixed those problems.
A WinRAR is you.
That's cool.
That actually looks really
I really
neat.
like that. Oh, they're still falling. My wall. My precious wall.
And your hot tamale.
And my hot tamale. My precious hot tamale. We're going to have to make that thing pulse at some point.
Yeah. I don't think that would take
Would
too
be
much.
like 5 seconds, probably, just animation.
You should just do it real quick. Yeah, just do it.
Alright, you pulled my leg.
We can just do it via script, too. Just
No,
do
it'll be
scaling.
faster just to do animation at this point because our animation system works now. So,
Oh, okay, good.
window, animation. Not that it didn't work before, it's just it's gotten
It works
to the point where it's
better.
good. Pulse. And we're going to go with transform scale. And let's see. Yeah, let's figure out something we can do with that. So we're going to
This is going to be
change
like the
the scale.
terrifying heart at the in Grand Theft Auto 4.
yeah, a little bit like that. We're not going to add a sound effect, so it's not going to sell it that great. But
okay.
going to go ahead and create a new keyframe here, and let's make it so that the scale is less, like 10 by 6 by 10, somewhere in there.
I think that works, actually.
That actually works better than I thought it was going to.
You know what you
right
should
off
do?
the bat.
There's one other thing that I want you to
Okay.
do with that heart.
All right, what do you want me to do?
I want it to spray blood particles when you hit it.
Okay, we can do that.
I know it's silly.
Yeah, it is, but it's something we can do.
I know. We should work on
I don't.
that.
I don't think I
after.
want to do the particle effect work right now for another particle. We've already got 2, which is more than like we do on. Like, remember how many times we used just the standard particle for?
Yes.
Paste component is new, so hopefully both the hearts will now beat in sync now. So that one's beating, and we'll shoot through and see if the other one's beating. Hard to
really
tell.
Look down. Yep.
It is.
It's cool.
Cool.
It actually does look pretty good. That's a pulsating hot tamale.
Yes, pulsating hot tamale. All right, so I'm going to save this scene, and I'm going to actually, let's see, let's organize our project real quick before I do the next part here. So let's create a folder. We're going to call this materials.
Not to be confused with
Right
materia.
in, and we're going to create a folder called levels.
Under materials?
No.
No. Okay, good.
Don't think we use wall test anymore. I'm going to delete that one.
But wall test, I was so attached. I hardly knew you.
And create C# script. No, that's not what I wanted. Create C# script. And then make it into a folder.
Okay.
Folder. What are we going to call this? Animations. I'm just going to, even though that's technically not an animation, I'm just throwing it in there.
Well, it is, but
It's kind of, it's a avatar or something, or it's an animator flow control thing. It's a state machine. All right, so what I'm going to do now, the reason I was doing that organization, we're going to save scene, save project, and we're going to create a new scene. We're going to play around with some procedural terrain generation for these castles to live in. And so I thought it would be fun to play around with that stuff. And so what we're going to do is we're first going to hit the asset store, and we're going to pick up one of the free examples from Unity.
hit up that asset store.
This is a really good example. It's a little bit dated, so there's some things I do in kind of a strange way, but we're going to just ignore that. And it has exactly what we want. It has height map generation, or it has mesh generation from height map in a script here. But I'm just going to import the whole thing because there's a lot of fun stuff to play with in here. So we're going to hit
Import.
I just want to make sure that this has a hierarchy that's not going to mix with ours wrongly. Looks okay to me. So import, and this is free from Unity. I would recommend every once in a while just checking the Unity Technologies plugins, because there's quite a
cool
few
stuff.
examples and built-in stuff, and all of their stuff is free.
Can't beat free.
Yeah, and all of them I think include open source stuff. There's a lot of models here that I wasn't
Yeah,
expecting.
there are.
There's more here than I thought there was.
Sounds like we need to get up on some of those models.
Yeah. So we now have our stuff in here. There's a lot of cool little demos in here. I'm just going to run through a couple of them real quick. Let's save this real quick. This is called terrain test is what I'm going to call it. And so, like, crumple mesh modifier shows you how to use noise on like a sphere, and there's like fractal textures, so you can generate textures based on. This is a perlin noise generation. Ironically, perlin noise is actually included in the MathF library for Unity now. It didn't used to, so this set actually has scripts to generate. What is it called? Where is it actually at? Control script, is that it? No.
I know you found it.
Oh, it's in plugins. That's where it is.
Aha.
Perlin. So if you want to see how Perlin noise is generated, this is a good place to look. So there's some stuff to play with here. There's like a cool little lightning bolt example, which has like actual geometry changing and stuff. There's a lot of cool little things in here. But the one we actually care about is the height map generator. And this was actually one of the least impressive demos as is. It just generates this, and it always generates this. This is all it generates. And what this is generate height map takes a height map and a material, and and generates the poly data based on the not the alpha, but the
Actually, isn't that the alpha?
it's actually it's based on the lightness of the image. Like, it just takes the grayscale value of the image. So like, you can see this image here, and you can see that the topology kind of matches that. So whiter is higher, black is lower. And this is actually really cool and really useful to have. There's probably other ways you can do this. I think Unity's built-in generation system supports height maps, but it's cool to have an implementation that's kind of laid bare for us. And we're going to do some code surgery on this thing and make it more useful to us. So I've mentioned perlin noise a couple times. I'm just going to do a quick perlin noise. Let's look at Wikipedia's article. Actually, perlin noise math fact looks better, actually. I think I was playing with this one earlier. So maybe I wasn't playing with this one earlier. Let's try that one again. All right. So basically, it generates noise that looks kind of like this, and if we apply that to a height map, we'd have kind of a rolling, hilly type thing. And perlin noise is not so what the difference is between perlin noise and like just using random is when you ask for a random value, every time you ask for that value, you want a new value that is equally random from the previous value. It should not have any relationship to the previous value whatsoever. Now, mathematically, it does have a relationship because there's no such thing as true random in programming. You can't do it. But you can simulate it pretty well, and basically they try and make it so the individual things, they're not trying to be as far apart as possible. Like, hashing functions try to have each thing be as far apart from another thing as possible. This one is things are if you get a 1, if you ask for a random between 1 and 5, you should get a equal distribution of 1 through 5 every time you ask, no matter what the previous values were.
Yeah.
It doesn't actually work exactly that way in practice, but it's close enough that that we use random. But if we did that, we'd just have what would look like a spiky nastiness. I might show you an example when we start changing the code. But it would just be really strange and noisy. It would look like the TV static equivalent of a mountain, basically.
Yeah.
And so what the perlin noise function is when you ask for a value at a certain value of perlin noise, you basically give it an input float, and then it gives you an output number. That value is close to other values that are close to each other. So, like, the closer the values are, the closer to the same value they will be.
Yeah.
And this is useful because then we can create kind of a continuous, slopey function with this thing. And what this represents, so if you were to look at just a line of this, you would notice that it goes from like light to dark to light. It doesn't just suddenly change dark in for a pixel, and then light for a pixel, and then medium for a pixel. You see this subtle gradient, and you can see this subtle in 2-dimensional as well. Now, Unity now has a built-in perlin noise function. They assume 2-dimensional. You can use it for one-dimensional things just fine. Just ignore the second dimension. And 2-dimensional perlin noise is probably the most common use case, so that's probably the reason that they did it that way. There's such a thing as 3-dimensional perlin noise. There's such a thing as in-dimensional perlin noise, although I'm not sure how helpful it would be in rendering. You could probably make some interesting things. But so let's go back to our terrain test. Actually, let's just keep generating height map. Let's just go with this height map generator example. Okay. So we hit play and it generates a height map. Not very exciting. So let's go into this script. And bear with me, this is JavaScript. I'm probably going to convert this on the show to C#. We're not going to start with that. And as I do it, I'll explain kind of how this script actually works. Right now, we're just going to do some, what I said earlier, code surgery. We're just going to inject perlin noise in here instead of a source image.
Okay.
So we've got what we've got here is a height map. So I'm just going to hit find, and we're going to find all the cases where height map is used. So we use the height map width here and height here. Okay, I'm just going to leave those alone. We use height map get pixel. Here's our key one. So this is basically going through and finding the values on the image and then applying the height to the vertex at each of these intervals. And the intervals are determined by the resolution of the object and the resolution of the material and a few other things. So what we're going to do is, instead of using getPixel.grayscale here, we're actually going to just replace this with our perlin noise function. So we do mathf.perlin noise, and this takes an x and a y in floating point value. Now we are getting ints of x and y, and I'm just going to throw them in, but this actually is not going to work, but I want to just put it in there anyway. So perlin noise xy, and then we will do the same thing down here, except for in this case we want, so we don't need the high mountain seal, we want x minus 1. This is for generating the tangents, which I'll explain later. And honestly, it's cool that the script actually generates tangents, because a lot of them just don't bother with this. Oops. Before I delete that, I want to. So x plus 1 on this one. So we're just going to replace this with x
plus 1.
So here we are. So if we hit play now, we have what looks to be a flat terrain. Now we still have this texture on it. I'm going to actually change the texture. We can do that by just getting rid of the material here. It will default it to, I think, a white material. So here we go. Now it's blue because we have a blue point light because they were being all fancy, and I'm just going to leave that because it looks cool. But you'll see that it looks quite flat. And the reason for this actually is because the perlin noise function at integer intervals will actually be 0. It will output like nothing. And you can read up more on perlin noise. You can read up more on perlin noise to understand why that is the case. So what we actually want is we want a good floating point value for this. And so an easy way to get that is we're going to add a variable, and again, I'm just deal with the JavaScript for now. Actually, you can do all this in C# as well. var will work in C#. It just basically means I want whatever this should be. And so I'm just going to explicitly set it as a float by setting it equal to a float. So we're going to do var noise scale equals 1.0f. And now we're going to use this, and we're going to place it into, we're going to divide both our components by noise scale in both cases. So in this case, we need to actually make sure that order of operations is maintained.
Yeah, you don't want to mess with order of operations.
It'll do things that you don't want it to do. And actually, if the tangents are broken, you probably wouldn't notice ever, honestly. But even if you have an artist, actually, your artist might be like, this doesn't look right. And then they'll be like, oh, there's a problem here. So now the other thing I'm going to do here is we have a function start here. I'm actually just going to change this to update. And so now it will actually generate height map every frame. And I'm just doing this so that we can see it going. We're probably going to have some script errors and stuff that deal with this, but I'm going to hit play and see what happens. So here we go. We've got script errors. They're just coming in. I'm just going to collapse them.
Go.
You can just see them going up.
Go.
And that's because we keep asking it to add a component. Actually, I'm just going to quickly remove that. I'm not going to. Who cares? It runs fast enough. So we're going to play. So now we have this tweak value. We have, on our generate height map here, we have a tweak value called noise scale. And if we tweak this up, all of a sudden we have some interesting results. And so we can change the scale, and the more you do it, the smoother it's going to look. And so we have a generated height map now, based on perlin noise. So this was actually pretty easy to handle right here. So we can adjust the bumpiness, but if we hit play multiple times, like if I set this to 25, right, and we hit play again.
Oh, but you need to send it 25
I
out
need
of
to
play
set it
mode.
25 out of play mode. So 25, we hit
What
play.
happened to the pink background?
I don't know. Which pink background?
When you hit play, yeah.
I don't know what happened to my pink background. Let's actually fix that right now. Mode 10.
Oh, it's nice and red.
Excessively red.
Fantastic.
It's kind of painful red, actually.
Yeah, it's a little bit painful.
Probably the encoder probably hates that too. I'm not sure if you've seen pure colors on encoders, but they hate them.
They hate them so much.
So let's make that just a little bit less.
Keep going.
Keep going?
Yeah.
Like that?
Yeah, that's good.
Well, now we won't be able to type things. No, that actually looks pretty good.
Yeah, it does. It's mellow. It's pretty.
All right, so we have our noise scale 25, and if we hit play multiple times,
right.
you'll see that it just looks the same multiple times. This is the same thing every time.
That is too dark.
Yeah, it's still too dark.
Well, let's not make it as quite as an offensive color.
All right. Go with some pastel type thing.
Pastel purple.
Yeah.
Oh, that is actually much easier on the eyes.
Yeah. All right. Oh, that
So
suits me.
Okay,
So-
25.
So as you can see, each time we hit play, it's the same terrain, which not very useful if you're trying to make a random terrain. So the way that you deal with randomness in perlin noise is if you want something to look different, you just change the offset within the perlin noise.
Okay.
And so we can. I'm going to add another variable here called noise offset. And this one I'm going to set up as a vector 2. And we're going to set it equal to vector 2.0. And we're going to add it in after we've done our noise scale calculation. So we'll add what is it called? Noise offset. So we're going to do noise offset.x and plus noise offset.y. Then we will do the same thing here. Plus noise whoops. How did that happen?
Whoa.
Plus noise whoops, wrong place. Set.x and then y plus noise offset.y.
Do you need to put those in?
And we need to put them in here too. Noise offset.x. Or were you going to ask something else?
Oh, I just like to explicitly put things into parentheses.
We don't need to put...
No.
Like, this one will work because of order of operations. So... And honestly, on either side of this, it kind of still functions. It just depends on how much mousing over you want to do. So if we hit play, we now have a noise offset. And if we adjust this, you can see that we kind of fly through the terrain. And you can see that it just continues to go here. And so if you needed to create like an infinitely scrolling terrain, you've already got it right here. This is a useful tool for that. So that's exciting. And if you just want it to be random, we can do a little trick to do that. So what I'm going to do is I'm just going to make it so if randomize, which is a value we haven't actually set yet, I'm going to just do var randomize, and this one's going to be a boolean. Is it boolean? Okay.
Doesn't go bool?
No, because we're on JavaScript. Var randomize equals false. We'll just default it to false. No, just false. False will be fine. And if randomize, we will randomly change the noise offset. So we will do noise offset dot x equals mathf dot random dot, it's not in math for some reason, it's in its own thing. Random dot range, and we'll do,
You could just do, honestly, like 0 to 25 or something like that.
Yeah, we really could do any sort of thing.
Any numbers.
But let's do 0 to... How do you do float max? I'm not going to worry about it. I'm just going to put a big value here, 5,000. And we actually want both of these to be 0.0f so that we get a floating point.
Yeah, I'm pretty sure that it just works with floats.
Yeah, it will, if they're floats. But if they're not floats, then it will assume that they're ints and behave slightly differently.
Unfortunate.
So this is just a hand-in. What
No
I'd probably
one has
put
no
in
F
there
after it.
would...
The 0
Oh,
does.
thank you. What I'd probably put in there if I was on C#, which we will be at some point here soon, is I'd probably change it to float.max, which I don't know if that works on
let's try
JavaScript or not. You want me to try it? All right.
Yeah.
Float.max. Oh, it looks like it does. Let's find out what it does.
Yeah, let's just try it.
So,
Why not?
Could actually probably do a float.min value as well, but not necessary. All right, so now if we click randomize, okay, for some reason this is very unhappy now.
It is really pissed.
So this is 0 and oh whoa. Okay, so we definitely don't want float max.
Apparently not.
Let's just do 500 like we were doing before.
500 it is. 500F.
Yeah, 0.0f. 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 Save. There we go. So now if we hit randomize, there we go. It's random. And so you can see that it just perturbs until you hit stop on this, but this is just an example of how this stuff works. So now you can see that it is indeed generating a whole bunch of different random terrains
Yeah, it's
based
freaking
on
out pretty hard right now.
based on the values here. And so yeah, so now we have random terrain generation part 1 basically done here. So there's a couple caveats here. One is our poly count. If we want this to be collidable, we're going to need to have the polygon count be low enough that that we have less than a certain number of vertexes. Like right now we have a huge number of triangles on here because they default the resolution. What is the resolution defaulted to? So it's the minimum. So it's maximum of 255 by 255, which is a lot of points.
Yes, that is a ton of them.
So that's the number of vertices, but then you would have even more than that of triangles to describe all of them. Let's actually look how this thing works. I'm going to go ahead and start. Is there actually really no new comments, or is it just,
comments.
or is YouTube stuck?
I don't know. Anyway, continue.
All right. So I'm going to start actually converting this to C# and we're going to describe what these things do. So we don't need the material. Actually, let's leave the material here. We don't need the height map anymore because we're not using it. We're using everything else. So I'm going to start converting this. So material is material. And that's what's used. That's what actually gets applied to it as a material after the fact. This is going to be a vector 3 size equals new vector 3. We're going to do float noise scale, vector 2 noise offset, and bool randomize. I think it's supposed to be bool in the case of C#, but it's still thinking that this is not C# because it's still called .js, which actually I'm going to fix right now. Let's go ahead and I'm going to create a new C# script so that we get our things that we need, and we're going to call this, what is it called? Height map generator. Yeah, that's what they called it. So I'm just going to call it the exact same thing so we can have as many problems as possible.
Sweet.
And that's... Did you see that? Can you confirm this? All right, I'm hitting Command A, and it's doing undo.
That's wrong.
Command Shift Z. Let's get all our stuff back here.
No, that's
I'm going to
very
quit
wrong.
monodevelop, and we're going to open it again.
Yeah, that's not the right functionality.
That was strange. So we have a height map generator.js and a height map generator.cs. We're just going to make sure that this is actually called height map generator because I renamed it wrong, so it didn't automatically do that for me. Hit save, and we're just going to grab everything here. Alright, that time I did Command A, and it asked me which file to open. File, edit, select all. Okay. I don't know what that is.
Very confusing.
Yeah. So we're going to paste this in here.
Command
Good, it did what it was supposed to do.
Good.
So I just guess that Command A is just on vacation for some reason. on vacation to be another. It just was tired of being the select all key, and
Yeah.
I don't blame it, man.
No, that's.
I mean,
that's
it's been
a
the
tough-
select all key for a long freaking
Yeah,
time.
It has,
So,
except in a few things.
So we can actually just go back here and we'll start getting errors now based on what we need. So it says something expected, and so already we have a problem. So these ones actually... Oh, wait. What happened here? This is in height map generator. Wait, what's wrong with this? Oh, it's because I changed... Okay, it's because I changed these things. We don't care about height map generator JS. We're going to remove that right now. Where is it? Height map generator. Die in a fire.
Oh no.
So now if I hit play, it's going to give us a bunch of errors. Actually, far fewer than I thought we were going to get.
Yeah, I thought there were going to be a lot more.
So mostly it has to do with just how things are declared, although I'm still going to go kind of line by line here. So our function here should actually be called void update because it returns a void, or rather doesn't return anything at all. Okay. MonoDevelop is being nasty today to me, and I am not liking it.
Yeah, MonoDevelop's being really, really a pain.
Alright, void generate height map. And so what this actually does is, first it adds a mesh filter to the object, just in case it doesn't have one. And it adds a mesh renderer to the object. And if it has a material, it passes that material to the renderer. Otherwise, it gives the renderer a color white material. Or it just sets the material color to white and assumes the default material.
Yeah.
So we have a mesh here. So this is a mesh, and we don't need the colon thing. And get component actually should be called differently from C#. So we want to actually do get component with the things like that. And same thing here. Int. Don't need that. Int. Don't need that. I'm going to explicitly call these ints because I don't like using var.
I don't either.
But it is a perfectly legitimate thing to do. Oh, we're not using the height map anymore, except we're still using it. So I'm just going to set it to 255 for the resolution. And where's height getting... Where are we getting... Oh, 255. So,
Bar vertices.
yeah, let's just go ahead and make these right. So this is a vector 3. This is a vector 2. Vector 4. We have a vector 4 now? Good.
Wow.
Yeah, of course we have a vector 4. We just don't have a whole lot of good vector 4 functions. 2 and vector 3. So this is so the way this works is for each height width combo there is a single point, and that's a vertex. And if we look at the way that this is generated, which we can't actually look at it just yet because there's a bunch of problems still. All right, add component. Do we have to use this? Is that the problem here? Save. Okay, that got rid of a couple of them. Let's see what else we need to get rid of here. What's the problem here? Cannot implicitly convert type vector 3. Oh, because it's not actually a vector 3. It's a list of, or a array of vector 3s. And an array of vector 2s and an array of vector 4s.
All sorts of arrays.
Getting down there. UV scale. What's the problem on this one?
I don't know.
There's a type when a
for a
variable
variable.
value or method group was expected. Okay. New vector 2. New vector 3. I find it interesting that on Java, evidently, you can do either or because they just kind of do it some... Oh, I see. It's because it's a list. Got it. Got it. I understand why they did that.
Next. Best overloaded method match.
Alright. Vector 2, UV scale. Best overloaded method match. Float has some invalid arguments. Okay, that's because these are not floats. Expressions note something. We'll just call this a vector 3, and we'll do new vector 3. I'm just cherry picking now just to get this thing to compile. So what's wrong with this one? Oh, because there needs to be a new here. Save. New vector 3, new vector 3. Oh, looking good. Tangents equals new vector 4. Oops, not unity exception. Just get rid of whatever's on there. Don't want it. And we uncover a few more. So, wait, what's wrong here?
Go back. That's, I don't know.
Oh, probably this. Yay. Alright, so if we hit play, hopefully it'll just keep working. Well, it doesn't actually keep working because generate height map doesn't have the script anymore. So I'm going to remove this, and we're going to put in our modified version called height map generator. And, oh yeah, we also, because we came from Java where everything is assumed to be public, we need to actually set things as public, because everything's assumed to be private by default on C#. Thank you. Sorry, I got into typing too much.
That happens sometimes.
Just want to make sure this still works. Looking good. We set the scale to something useful, and we randomize. Yeah, everything looks pretty happy. So, what are we doing here? So, what this thing actually does is it goes through here, and this is where it determines the height of each vertex. And so the vertex position is set to X, Y, and pixel height. And then they scale it based on the size scale. So this is kind of a little bit of a interesting way of doing it, but it works. And so what vector 3 scale does is it just returns the position as if you were to scale the second point based on the first scale, or the second input as a point and the first scale. And so that's how it positions everything based on how wide, like we set a size here, so that's determined for the size scale here. Because the size gets propagated here. Let's find it through size scale is size.x, size.y, etc. And so it just generates these points, and then it generates tangents here. Tangents are used in some advanced shaders. This is a good generic tangent generator math here, so you can probably pick this out and use this in your own projects. For whatever reason, in Unity, there's not, as far as I know, a way to automatically calculate tangents. There is a way to automatically calculate normals, though, and that's what they use for the normal stuff here. So it gets all these points, and then for each of these points, it goes through here and it generates a triangle, or the number of triangles it needs for the points. And so so they basically output 2 triangles per grid cell, and those are, when we hit play here, and we have it just as a flat, it's really easy to see. So each of these squares is 2 triangles, and that's what these triangles represent that it's generating here. And so it goes through and does this for every single one except for the last row of vertexes, which it just ignores making more triangles so it doesn't go over bounds. And then it sets the triangles to this triangle list that it just made, and it recalculates the normals, and it assigns the tangents, which you want to do after the normals for whatever reason. And the normals are the vertex normals, so that's what you get. That's how you get the smooth shading. If we change the way that the normals were calculated manually, we could get like a flat shading style thing if you wanted to be more like Tron style or old school vector, like here, fractal terrain. Although oh yeah, it's all beautiful now. I remember when you search for fractal terrain and all you would get was flat shaded stuff.
Yeah. Wow.
Yeah.
This is ridiculous.
Everything's just sweet looking now.
Apparently.
Something more like this, but that's not even shaded, so it doesn't really make it. Yeah, fractal terrain, flat shaded. God, I can't. Okay, there we go.
Okay.
Yeah, why not? We'll use this as an example. This kind of has the flat edges thing, and they reflect.
Darwinia.
Yeah, Darwinia is a great game. So, so that's the reason it's smooth, is because of the normals and stuff. It's also smooth because we have a really high resolution. Let's also make it so that we can actually change the resolution now, because right now we are just putting in 255. Let's make a public. What do we want to call it? Public float. No. Public int resolution equals 255, and then we just
so
throw
slap that same
resolution.
number in both of them.
Yep.
Yeah.
We'll assume square aspect ratio. You could always play with this and adjust things on your own if you wanted to.
You can always
change
add
that.
another variable.
So if we now change this to resolution of like 64, we should see.
Once you up to the noise scale.
Here, let's actually make sure this is working for us. So you can see it immediately. So like here's a resolution of 10, and then we can make the noise scale, and you'll see that.
That's actually surprising. Huh?
Now, see how smooth it is. That's because of the normals. That's because of the lighting that we're doing. But it's not actually that smooth at all.
No, it's not.
But you can see by the sharp edges. But the lighting on it will be smooth because the normals are calculated as if they're coming out of the vertexes rather than towards the triangles.
Neato.
Kind of hard to explain that right now. And I'm not going to show how to do the flat shaded stuff on this episode. That's outside of the scope for right this moment. So now we can adjust our resolutions, and so now we can actually get something that's closer to a usable size. We could also potentially have a separate resolution for. Let's add a couple more things here. Public bool generate collision mesh. Public bool or public int collision mesh resolution. So we could basically use this to create another mesh for the collider that is lower resolution, and it will still match the contours pretty well.
Oh, okay.
So I'm going to go ahead and take a stab at that right now. So this does everything we need to assign the mesh. Let's see what we do for collision mesh. So if I do game object dot add component, and we do mesh collider. So we're going to do that, and then we're going to take our, so this collider dot mesh. No. Collider dot accessing a collider mesh in script. Good old Google.
Google has all the answers.
So mesh collider. Oh, it's a subclass, so we probably have to call it a actual. So let's game object. Actually, maybe we can do this. Collider. We'll cast this to mesh collider. Not sure if this will actually work. Dot mesh. No. I already have a problem here. I'm probably doing my typecasting wrong. Alright, let's do it the other way. So add component, does that actually return the component when you do it?
I have no idea.
Game add component unity. I think it does. I'm just going to double check. Yes, it returns the component that you want there. So, so I think what we can do is just do mesh collider col equals game object dot add component mesh collider as mesh collider. So now if we do col dot mesh shared mesh. All right, we have something.
Fantastic.
Yay! All right, I think it only has a shared mesh. It's kind of weird. You would think that there would just be a regular mesh too, but
You would think
that probably
so.
won't cause any problems. So we're basically going to want to run through this process twice now. So where does this process actually start? Here it is. So I'm going to actually break this out into a separate call.
Okie doke.
Good time to use the word actually again. Void actually generate mesh.
For realsies.
For realsies. So, what do we want this to do? We could just have this. Probably getting too fancy here, worrying about doing a separate collision stuff, but I kind of wanted this to work nicely and also look nice, so let's power through this. So let's have it where we give it a mesh. So this thing will actually take a mesh. Actually, we'll call it a mesh input mesh, and we will throw all of this into here.
Whoa.
That wasn't paste. Oh, maybe it was. Okay.
What just happened?
I don't know. It's just been funny like that. I'm doing this just so I don't shoot myself in the foot later.
Yeah, good call.
Because it's there. So this now takes a mesh, and what we want to do is actually change all of the mesh references here to the input mesh. So mesh. So it's just there, 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 and there. So we just change all those to input mesh. So let's see if this actually works. We need to actually hook this in now. Actually generate mesh, and we give it our mesh.
It's a lot of mesh.
It's this whole mesh of mesh. So let's see if it still works. Hit play. Wait for my computer to spin up.
Beach ball.
Oh no, did I do something wrong? I must have done something wrong. What did I do wrong? Let's see what we lost. Probably wasn't too much. Probably just the generate height map thing here. Yep, missing monoscript. Let's remove that. Throw height map generator back on. I think we're back in business, other than the fact that it's probably going to crash if I hit play right now. So let's figure out why. So we have to actually do something special to make this something that we actually can modify.
I do not know.
Let's do ref. See if that.
You should look at the console real quick before you play.
Ref.
See if the console actually says anything. Oh, there you are.
Okay, it's done. Hit play. It's probably gonna crash. No idea why. Actually, there's probably several thousands of reasons why. So I should have saved that scene again. I don't think I did that, did I?
No.
I'm good at this.
Well, it's just, you know. You
So
don't
height
know
map
how to
generator, go back,
reset
kill the
the
mono
scene
behavior.
real fast.
Put height map generator on here, hit save. So I think what's happening here is width equals resolution. Well, that's fine. Yeah, I'm not sure.
So comment
exactly
if you comment out the
why.
call to the actually generate mesh, it'll probably work, right?
I would imagine so. He's not doing a whole lot at that point. Yeah, it's working. Doesn't do a whole lot, but it's working.
Whoa! Did you see that?
Yeah, it's probably from the console, even though
No,
that's
look
not...
at how many.
Oh.
It's adding mesh colliders.
Oh,
like,
that might be the
constantly.
problem. Oh, there's no limit to
Yeah.
the number of mesh colliders, so we actually do
Woo!
have to care. So that's good to know. I'm not sure if that's actually that might have been causing the problem. I don't know. I don't see why that would actually cause the problem. But let's just do if not game object dot has component get component mesh collider. So that should return if, or rather, we'll explicitly check for null equals null.
Good
Then
call.
we'll do this, and if it already has one, it will not do another one. Save. Let's see if it solved that problem. All right, that problem solved. We have one mesh collider. Good. Let's go ahead and fix that on these two lines here too.
Oh, we should save the scene and everything.
Yeah, good call. Okay. And so this time we're going to use mesh renderer and mesh filter. Save. And save the scene. And save the project. Hit play. Alright.
We still only got one collider, one render.
So it's... Yeah, so this time we shouldn't have any console output whatsoever. Looking good.
Good, good.
Let's see what happens if we... So we've saved this, right? Everything's
Yes.
saved. Save
Yes.
project,
Yes.
save scene, save. Because this still probably is going to fail.
Well, let's see
So I
what
don't
happens.
actually know why it was failing before. So let's hit save and hit play. Oh, no, it worked. Okay, so the problem was something to do with
There were
a whole bunch of
too many mesh colliders. Didn't know which
So
one
if
to
we
modify.
hit randomize, or if we hit noise scale, everything seems to work. Yay, all right. So now, since we can actually give this thing a mesh, we can also do that for our collision mesh. So what we'll do is we have a collision mesh resolution. I'm going to set this default to
Same thing as the regular resolution, I would think, right?
I actually want it much lower than that.
I know,
default.
but by default...
No,
well,
no.
okay.
By default, we want it to be under the 300 poly limit, or the 255 polygon limit. So let's see. What's the square root of 255?
I don't know. Bad at square roots.
Actually, wait. That's... So 12... Yeah, we'll just do 12.
Yeah, 12 sounds good.
Much lower resolution for the collision mesh. We'll see how it actually matches up too. So collision mesh resolution is 12. I have this bool. I'm not actually checking it yet. I'm not going to worry about that just yet. So then we're going to do actually generate mesh, and then the reference we're going to give it is where is it? Col.mesh. No, col. Dot. We do have this. This is a thing, right? Oh.
Square root of 255
Oh,
is about 16, by the way.
16? All right.
Yeah.
Let's make it 16 then. I like 16.
It's actually 15.9
I guess
something.
that makes
something.
sense. Oh, it is?
Yeah, it's 15.9687.
Oh, okay, 16 because it's 256.
It's 16.
Yeah, we'll do that. I don't know why I didn't just remember that. Mesh collider col. So the problem was we don't actually have col anymore because we are announcing it in this if statement and then it just disappears. So now we have it, and we can just do col dot mesh, and we'll just grab the shared mesh. Although we might have to set that at some point. We're probably going to have an error here. Unassigned local variable col. Oh. Oh yeah, because it might not be assigned. If col does not equal null, then we do this. Save. Still doesn't like me.
No, it does not.
Oh, and we'll just set it to null to start. Who cares that it's not assigned?
Unity.
Best overloaded match for...
Height map generator actually generate mesh.
Oh, I need to actually make it a reference. Ref. Property or indexer mesh collider shared mesh may not be passed as ref or output parameter. Okay, I kind of figured we were going to run into that situation. So what we're going to actually do is we're going to create a mesh collision mesh equals new, actually, we'll just do new mesh, I guess. See if this works. And we need these probably. Let's get rid of my search so I'm not confused by that. And so collision mesh, so we're going to use the reference to our collision mesh, and then we're going to actually set col.mesh shared mesh equals collision mesh. Let's see if this works. It compiled. That's a good start. So we hit play, and I think I did something that made it unhappy.
It seems pretty unhappy.
I'm not quite sure what that was this time. Alright. Let's kill it. Unity. I choose you. Height map generator. So, what did we do here? We're setting the shared mesh to a new mesh. We have a mesh collider now. Changing collision mesh at runtime Unity.
Do I have a question about delegates, if we've ever used them?
Yeah, we've done a couple of episodes with delegates. We generally have avoided them just because, I don't really know why we've avoided them. It just hasn't been... we definitely have done a couple for, like, registering to receive events from our own scripts and stuff, but we haven't done a whole lot of work in that field. They're useful. We'll probably find some good use for them at some point in the future, but I don't have an episode that's just like, let's do delegates.
We haven't delegated time for delegates.
Yeah. Add the mesh collider component to the same object after you finish generating the procedural mesh itself. Okay, so that just is for automatically generating a collider based on the mesh. This is a little bit different because we're trying to do this in such a way that so where's it actually dying here? Let's try let's see if we can debug this. Start debugging. Oh,
Whoa.
what? Wait,
Huh?
what was that screen coming up for?
Um,
I didn't even think that was possible.
um,
So, is it doing things? Do I hit play? Will it work now if I hit play? Like, if I hit play, can I pause it somewhere in monodevelop land? No, I don't see.
No, that does not look to
It's
be
not
the
running.
case.
Why is it opening?
I think debugger works differently now.
All right, I don't have time to deal with that
debugger?
right now. Yeah. This has been a... Yes, reopen them. I don't care. It didn't reopen them anyway.
Let me ask you a question that I'm not gonna actually be able to. No, it was the Unity.
Oh, yeah.
That went nowhere. That's
All
me
right.
tripping over my own feet.
All right. So if col does not equal null, actually generate mesh, collision mesh reference. So this just wants a mesh. All it does is apply things to the mesh. We have it as a new mesh. Where's it getting stuck?
That is a very good question.
Oh, maybe it's a problem of it being the wrong resolution. So let's actually change this so this actually takes resolution parameters. So int resolution. I'm going to call it input resolution to keep it separate from our other resolution variable. And so now when we call this the first time, we're going to use resolution. We call it the second time, we're going to use collider resolution. Oh, what is it called? Collision mesh resolution. Blah, resolution. Alright, save that. Let's see if this just fixes it. Hit play. It worked! Oh my god. Null reference exception. Lots of them. Call.shared mesh. Object instance not set to instance of an object. So I wonder which one's not set to an instance of an object. So the shared mesh equals collision mesh after we've twiddled it.
Twiddled it?
Yeah.
Is that a technical term?
Yeah, totally. Actually, it is a technical term when you twiddle bits, at least. But,
Oh.
which sounds really
It sounds
naughty.
like a song.
Twiddle my bits.
Twiddle bits just a little bit.
Alright, so
What's the problem and where is it at? What's the message that you're
I'm getting a object reference not set to an instance of an object.
For which object?
It doesn't tell us. So it's one of these two objects. So let's find out.
Well, what's collision mesh first?
So collision mesh. Let's do debug.log collision mesh. I don't know if this is actually going to give us the information we want. Let's just try it. Hit play. Alright, so it is a mesh indeed. It's not now if I was to say something like collision mesh equals null. Does it actually say null when I print it out? I just want to make sure that this is actually useful. Yep, it's null. Alright. So it does seem to think that it has a mesh of some kind. Maybe, so
There's a question of how are we trying to debug? If you didn't catch it, just clicking the play in the top left, because that should work. Apparently you can just debug by clicking the play in the top left corner.
Alright, I will give it a shot. Oh, much better.
Whoa. Whoa, that's awesome. Thank you.
Alright, so col.shared mesh is
that is fantastic.
a problem. So is it possible I can't set the shared mesh? Or is it because mesh collider is not... Oh. Wait. How does add component? Add component. Just want to make sure we're doing it right for C#. No example available in C#, but this is C#. Alright. No, we did it right. Alright. So if I do just col, does that actually exist? Save. So if we stop this and hit play.
Something about the word
null.
Instance as well.
So it's still null reference. What's
No, it said instance up there. I noticed there was a warning that said something about...
How do I get rid of this horrible display?
I don't know. Like that?
No, it's still there. Y dot.
Wow, why is it just stuck there?
Yeah, sure, whatever. Maybe I shouldn't have chosen save and close, because now I have a beach ball. You can't see the beach ball, but trust me, it is there.
Yep, there is a beach ball.
Alright, let's try. We're squidding it.
It wasn't responding.
So, can I have the old version of MonoDevelop back? Is that a thing that can happen? I don't even care if it doesn't debug with the new version of... Because I don't really use debug that much anyway in my own practice, so... I'm too used to not having good debug tools. So somehow col is null.
Because if col is not equal to no...
Oh, I know why.
Why is that?
I got it. It's because the first frame it works, but the second frame and all subsequent frames it doesn't work because col's not actually set to anything anywhere. So this isn't safe. So instead of doing that, we're going to set col here. Mesh collider col equals game object dot get component mesh collider. So this might actually work this time. Let's see what we get. Hit play. Failed setting triangles. Some indices are referencing out of bounds vertices. And I know why that's happening actually. It's because we are using where is resolution? Oh, okay. So is there some hard-coded values here or something?
Does not look like it.
Failed setting triangles. Referencing out-of-bound vertices.
Oh wait, it's so... The triangle's index is probably the problem.
Yeah, we aren't getting that if we don't do this, right?
Well, let's take a look.
Okay, yeah, it works fine in the case of... So there must be some
The terminal
assumption we're
one.
making.
Well, let's go down to that triangles, because it's saying that's out of the bounds. I bet it's trying to put more triangles than it should in an area that is not the right size.
Doesn't
seem
look like it,
would.
but let's maybe it's again just too big or something. Let's set this to 10 by default, and let's actually change it so that it will be 10. Collision mesh resolution. Oh, the collision mesh resolution was 0. Maybe that was the problem.
Was it seriously 0?
Yeah, it was seriously 0 because we had set that variable before we had actually given it a default value. So that might be the problem.
That's the problem.
It was the problem.
I'm mad.
All right, so we don't need to have the debug log in here anymore.
No, we don't.
Oh, wait, no, that may not be the problem because we didn't actually change this back yet. So let's find out. Hit play. Looking good. All right, so let's see how good we're looking. So
that makes me so irritated.
Let's go ahead and change the noise scale.
Look at all that noise.
And now if we click on it in the scene... Oh, it doesn't look right, but it's there.
It's there, but it's not generating the proper heights.
What? Why do I feel like a noob tonight as far as using Unity for some reason? Feels like every click I make is wrong somehow. Alright, so this is eating my CPU. Hopefully we're not losing frames or anything.
Are we losing frames?
But yeah, so, what does that mean? So, if col does not equal null, actually generate mesh. And so it should be doing that every frame. Just like we were doing before.
Yeah.
And col should not equal null ever after the first frame or anything.
So...
Oh, there we go.
Oh, interesting. At some point it just stops.
Oh, I know why.
Okay.
I think I know why. It's because of some assumption we're making about the resolution to the ratio. Alright, so x divided by noise scale plus noise offset. Maybe we need to make it so that... So the problem here is x only goes between like 0 and 16 in this case, whereas on the other one it goes between 0 and 255.
And 255, yeah.
So in order to get the same range between the two... There's a few ways we could probably fix this, but let's see what the best one would be. So...
Well, where are we? Are we using width anywhere? So vertices is height times width, times height times width. That makes sense.
Alright, so... Let's create a ratio. So we'll do x divided by... No, that doesn't really help, does it?
That's probably right. Somewhere in here, right?
Yeah, so...
Where we're multiplying by width?
Yeah. The problem isn't that. The problem is actually indefinitely in here. Because this is going to be generating a different value because the x is going to be lower. So what we want is... Let's try doing x divided by width divided by noise scale, and y divided by width divided by noise scale. This one actually will make it so that at 1 it'll probably work better too.
Okay.
And do we need to do that anywhere else? Yeah, probably here. Yeah, divided by width divided by width, and we also need divided by height for the y. So in this case it's okay, so we need height here, even though they should probably be the same.
The exact same number, so it shouldn't matter.
I guess it doesn't really matter, but I'm going to do it just in case we were going to change it later.
Just for portability.
Yeah. Y divided by height, y divided by height. Let's see what this does. Hit play. And so now we do our noise scale, and it's not working at all.
No, it's not working.
Because I know why.
Should we be multiplying by one?
It's because this needs to be a float. float width. And then float height, float width, float width, float height, float height. Save. Play. What do we got going on here? Looking better because we actually have a curve already, which is what I was expecting to see. Although now our values are way different.
Whoa.
I think I might change something to a multiply here. Let's see if this fixes.
Maybe multiplying it by width?
I'm going to change the multiply noise scale here. Math.
Math is fun.
Times noise scale.
That was not sarcasm. I actually do enjoy math. Do we want y times height instead of divided by height?
Wait. Oh, what is
Wait,
this
why
last
are
thing?
we-
We don't want to do this at all. This is y. We want to do it here. Y divided by float height. And why aren't we scaling the noise on here? Found a bug. Alright. Let's try
Well.
times noise scale.
You know, bugs.
Alright, save.
Let's try this again.
Try this again. Hit play. Let's see if the... So now it acts kind of like we did. It acts in a slightly different way than we did before. I don't care.
I actually kind of
good
like
enough.
that better.
And then we go to scene, and let's see if this approximates a little bit better than it was doing before. Hard to tell.
I think it's a little better. Seems actually kind of reversed.
Alright, let's lower our resolution to 32. Let's see how it looks in that case.
Because we should start seeing about a 1-to-1 on it.
Yeah. That's looking pretty close.
Yeah.
Yeah, that's actually working right. It's just that there was such a discrepancy between the collision mesh resolution and the... you'll see how high we can actually change this before it...
Oh,
fucks
wow.
up.
Look at that.
Huh. I thought
So
that it
it's a little
supported
off,
far less than that.
by the way. I mean, I guess if you had it the exact same, like 32 there, it would look the same.
So like 32, it should look exactly the same.
Which it does.
I mean, there's going to be some crawl just because of the difference. That looks right. That looks exactly right because it's following the contours almost exactly as it tightens up. See?
Yeah.
I'm curious about how big a mesh. Max collision mesh triangles. Unity. Why do we need collision detection? Alright. Mesh collider.
Why do we need
Triangles.
colliders? Jeez.
Convex mesh colliders are limited to 255 triangles. That's really, really low in the case that we're doing here.
Yes.
Let's actually find out how many it is. Let's do debug.log collision mesh dot triangles dot length. Just to see what we're generating here, because I have a feeling we're already double even at 16. Oh, we're more than that.
Holy moly.
Yeah, it goes real quick. So 10.
Wow. many triangles.
No. I imagine 8's probably really close to what we want. Still not enough.
7.
Wow, that brings our resolution way the heck down.
Yeah, it does.
Yep, we're now under our 255 limit. Doesn't seem to be complaining about the limit right now, though, which is... Usually it does, doesn't it? Yeah, that height map is not going... That's not going to work. Oh, God.
Whoa.
It does some fun things when I slide these things around. Noise scale... Yeah.
Actually, that does make sense with what's happening.
I think we're generating too many triangles because this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13. So 12 times... Oh, wait, maybe it is. Yeah, 12 times 12 is 144. So we are generating too many somehow.
Yeah.
Because we got 216. How are we getting 216?
I do not know.
So... Probably should have played more around with this at home before I did the show, but...
You know,
we've got some things. We've got some things going at least.
Yeah.
We're on our way, I think. We're just gonna have to figure out some of the little problems that we have. It's really cool that we can just slide these things in and out, and they just work.
For the most part.
Well, if I slide them out, they freak out for a moment, I guess.
Yeah, it doesn't like that at all at first, does it?
It's kind of cool.
It is kind of cool.
Oh, God. Slowing down my computer again. All right.
Well,
that's enough for tonight. We're already an hour and a half in, aren't we? All right. Cool.
All right. Well,
so let me just save. We've got a basic generation thing. We just have some things to work out, and then we can start plugging it into the game. So thank you very much for joining us tonight. You can email me at pushypixels@pushypixels.com with any questions that you want. And seriously, just email me if you have questions, or if you want me to look at a problem, just send me your project or send me your script example, and I'll help you out with it. And you can also tweet me at Drakfire.
Yep.
And you should buy Phil's game Robot Alone.
Why, thank you.
Yeah.
You can email me
You're
if you want to. It's philip@protosoftworks.com. Or you could tweet me at magmalemur on Twitter. And you should also donate to Cooking with Unity. Donate to Cooking with Unity. It's good times. If you donate a certain amount, you can get a coaster.
That's true. And actually, yeah, I've got a pile of them now because we're actually shipping them out this week. So here's our finalized coaster right here. And we've got like 8 of them right there, and we're going to have a few more to get everyone who has sent the money in for the donations. Well, I'll be getting those shipped out probably, I'm going to say Wednesday. I'm going to try and do it tomorrow, but I'm not sure if I have the time. But I should have time on Wednesday to actually get that packed up. And those will be sent out to everyone that I have on my list that has donated over $20 or $20 or more. And again, if you have donated and you expected to get a keychain and you have not gotten a keychain yet, please email me, pushypixels@pushypixels.com. Anyway, I actually was pretty happy with tonight's show just because I like doing math stuff and we were playing with some code, and hopefully it wasn't too fast or too strange for everyone. Again, if you have any questions, email me, and you guys have a great week.
Yep, I'll be out next 3 episodes, but y'all have a good
That is correct. We will miss you so much, Phil.
Oh, I don't know.
Myself especially. Like, I die on stage here without you. So, we're probably not going to continue the artillery thing next week because Phil wants to stay in the loop on that one. So we'll have some other special episode instead.
And unfortunately, I get to miss out on the 2D stuff. But, I should probably go see family and stuff like that.
Yeah,
so.
We got too much demand on 2D for me to not do the 2D episodes right now. So, Anyway, thank you very much for joining us, and you guys have a great week. And you won't be here for this Thursday.
Yeah, well, yeah. No,
oh, you won't.
No,
Okay.
I won't. No,
no,
I
you
won't.
Okay.
No.
So I'll see you on Thursday for 2D Thursdays,
and I'll see you guys towards Christmas.
Yep, around Christmas. You have a good trip, man.
Thank you.
Enjoy Cali.
I will.
All right. It's gonna be a lot warmer than here.
Yes, it will. Have a good night.